We're now going to talk about the properties of different resistors. We're going to start off with an ohmic resistor. So ohmic resistors are normal resistors represented by a rectangle at a constant temperature. And if we were to plot a potential difference on the x-axis and current on the y-axis, we would get a perfectly directly proportional relationship. So that's directly proportional, which means it is a straight line going through the origin. Straight line going through the origin. And again, this is for any normal resistor or any Y at a constant temperature. It's got to be at a constant temperature. A filament bulb has a different pattern, has a different graph. Again, we plot potential difference on the x-axis, current on the y-axis, and we get this S or F shape. So if we cover up the two curved bits, we have a directly proportional middle section, so to speak. But at this point here, the current starts to tail off, starts to plateau. It does not curl down, and the reason why that current plateaus is because the resistance has increased. Resistance has increased, and that's because the temperature has increased. So if temperature increases, resistance increases, so the current is going to find it hard and hard to flow, so the current plateaus. And that's for a filament bulb, which the circuit symbol is a circle with a cross in it. Diodes, which is a triangle in a circle with a line through it, that has a very specific graph as well. Again, potential difference on the x-axis, current on the y-axis. And what happens is the current is zero until you get to a threshold point, and then the current shoots up quite rapidly. So the reason why there's no current on this side, no current, is because the resistance is very high. Resistance is very high. And in the other direction, the current is high, so it's got high current, so low resistance. The way we could look at this is, in the positive direction, we've got high current, low resistance. In the negative direction, we've got no current. So we think back to our circuit symbols, the direction the arrow says only current can flow that direction. So in this direction, it's positive, we get a current. In this direction, negative, no current because we're going against the circuit symbol. That's the purpose of diodes, to only allow current to flow in one direction. We've also got two other types of resistor. We've got LDRs, light dependent resistors, rectangle, circle around it, two little arrows representing light. And what happens with LDRs is their resistance changes with brightness. So R on the y-axis for resistance. On the right hand side of the x-axis it's bright, on the left hand side it is dark. And when it's dark, the resistance is high, and when it's bright, the resistance is low. And it's not a linear graph, it decreases like that. So again, LDRs, when it's dark, the resistance is high, so we've got low current. When it's bright, we get low resistance, so we get high current. And thermistors, which is again a rectangle representing resistor, hockey stick through it, they have the same pattern. They have the same pattern of resistance decreasing, but this time instead of responding to brightness, they respond to temperature. So hot, cold. When it's cold, resistance is high. When it's hot, resistance is low. So when resistance is low, we get a high current. When resistance is high, we get a low current. You will need to be able to recognise, draw, interpret and describe these graphs for ohmic resistors, filament bulbs and diodes. You'll need to be able to explain what diode proportional is, which is a straight line through the origin. You will need to explain what happens to resistance when it gets darker or brighter in terms of an LDR. You need to explain what happens to resistance of a thermistor when it gets colder and hotter. So we talked about how if it's cold, resistance is high; when it's dark, resistance is high; or when it's hot, resistance is low; when it's bright, the current is high. So we talked about current. If the resistance is low, we need a lower potential difference. If resistance is high, we need a higher potential difference to make the current flow. So that is useful in potential dividers if you've got more than one component in a circuit.